Hello and good afternoon friends, welcome to CEC EduSet live lecture. Dear friends, in yesterday's lecture we tried to understand about air pollution, and under air pollution we discussed about particulate matters. Today also we are going to continue our lecture on air pollution only, but today we are going to understand about gases pollutants. What are gases pollutants, how they contribute in the air pollution or causes air pollution. So we are going to discuss this, as well as we are going to know the effects of air pollution. For this we have again with us in our studios Dr. Arun Srivastava. He is an associate professor in School of Environmental Sciences, JNU. So first of all, I would like to welcome our guest Dr. Arun Srivastava. Sir, welcome to the EduSet lecture. As we discussed lots on this air pollution, and we try to understand what are those particulate matters which contribute in the air pollution. So as per the discussion, today we are going to talk on the gases pollutants, and after that what are the effects of the pollution. So over to you, sir.
Thank you. Good afternoon everyone. So we'll continue the previous lecture, in fact in which we discussed air pollution, especially the particulate matters, but one very important component of air pollution, that is gases pollutant, was left. So we'll have an elaborate discussion on the gases pollutants. So starting from gases pollutant, if we see this slide, we can see that more or less there are so many gases pollutants, over hundreds of gases pollutants. If we divide it on the basis of the alphabetic letter they start from, so it covers more or less all the letters of alphabet. So but it is very difficult to tackle all these gases pollutants. So what we have done, we have defined some criteria air pollutants depending upon its presence in the atmosphere and its impact upon health. So coming back to the air pollution, coming back to the criteria gases air pollutants, there are few gases criteria gases air pollutants. There are mainly 6, and it starts from carbon monoxide. And carbon monoxide is basically a colorless, odorless, tasteless and poisonous gas. It is produced instead of CO2. In fact, in fact CO2 should be produced, but instead of that, in some special circumstances, CO is produced. And what are the reasons when CO is produced instead of CO2? When the oxygen supply is less, when the combustion chamber is temperature is less, when the gas residence time in the combustion chamber is not sufficient, and when the combustion chamber has some kind of turbulent environment. And one more thing I would like to say, that the probability of CO2 production is very, very less in a stationary condition than mobile sources. So the CO CO we observe, it is the product of mostly non-stationary sources. And again coming to CO, so it's, as far as some of the characters are concerned, it is a kind of asphyxiant. It actually interferes with the blood's ability to carry oxygen from lungs to the different parts of our body and tissues. So thus what does it do? It actually combines with the blood and forms a compound that is known as carboxyhemoglobin, COHB. And in fact HB has more affinity towards CO has more affinity with hemoglobin than that of oxygen. So the chances of CO getting absorbed with hemoglobin is more. So even a presence of very small quantity in the atmosphere becomes lethal. And what happens afterwards? So this CO which is being absorbed in the hemoglobin, instead of oxygen, it goes to the brain, and there the brain feels the deficiency of oxygen. Thus it starts pumping at a faster rate, and this can cause sometimes severe health problems, including heart attack or some other ailments. Now the next criterion pollutant is oxides of nitrogen. There are around 7 oxides of nitrogen that can be present in the atmosphere. They are NO, that is nitrogen monoxide, NO2, NO3, N2O, N2O3, N2O4, N2O5. But there are only 2 which are considered to be important air pollutants. They are nitrogen oxide and nitrogen dioxide, that is NO2. And in fact together these 2 gases are known as NOx. As far as their production is concerned, there are 2 types of NOx which are produced. One is thermal NOx, another is fuel NOx. What is thermal NOx? Thermal NOx is created when the nitrogen and oxygen are heated in combustion chamber at a very high temperature. So they are fused together and form nitrogen dioxide. And the fuel NOx is created by the oxidation of nitrogen compounds when it is chemically bound with the fuel molecules. So this is known as fuel NOx. And as far as its characteristics are concerned, NOx is a colorless gas, and it irritates the lungs, which can ultimately cause the bronchitis, pneumonia, and other respiratory problems. Apart from that, it can also react with VOCs in the presence of sunlight to form a very hazardous air pollutant that is known as photochemical smog. The next one is VOCs, and it's known as volatile organic compounds. Volatile organic compounds are organic compounds having a boiling point that can range between 50 to 260 degrees centigrade. This class of compound include unburnt hydrocarbons emitted when fossil fuels are not completely combusted. They enter into the atmosphere when solvents, fuels, and other organics evaporate. There are some natural sources, such as, apart from the anthropogenic sources, there are some natural sources too. There are deciduous trees and shrubs and conifers. In fact, the transport sector is responsible for 1/3 of the VOCs, anthropogenic VOC produced, and industrial sector is responsible for 2/3 of the anthropogenic VOCs produced. Exposure to VOC can be very, very harmful. It can cause both acute and chronic health effects. The next one is photochemical smog. What is photochemical smog? In fact, when oxides of nitrogen reacts with VOC in presence of sunlight at a temperature over 18 degrees centigrade, some complex compounds are formed, combination of complex compounds are formed, that is known as photochemical smog. In fact, photochemical smog is comprised of several, maybe tens of hazardous chemicals, but the main pollutants are ozone and peroxyacetyl nitrate, that is also known as PAN. And these two, especially O3 and PAN, are serious health hazards. It can cause serious health effects which can ultimately lead to death. If you recall, the 1952's great smog disaster in London, which actually caused over 4,000 deaths in just 3 to 4 days, were caused by this photochemical smog only. The next one is ozone or O3. What is ozone actually? The ozone is an allotrope of oxygen, heavier than oxygen. It is found in both the layers of atmosphere, that is troposphere and stratosphere. Stratospheric ozone are natural. In fact, they are advantageous or beneficial to us, while tropospheric ozone is not beneficial to us. They are known as pollutants and they are very harmful to us. Here, what we are discussing is stratospheric ozone, or the ozone which is at the lower level and considered to be a pollutant. The majority of tropospheric ozone formation occurs when NOx, CO, and VOCs, such as xylene especially, react in the atmosphere in the presence of sunlight. The reactions are given here. How CO is responsible for the formation of O3. CO reacts with oxygen in the presence of sunlight and forms carbon dioxide as well as oxygen. Another is oxides of nitrogen, bioxides of nitrogen. Oxides of nitrogen in presence of sunlight break into NO and O radical, and this O radical combines with oxygen molecule to form O3. So CO and NO NOx can be said as precursors of ozone, as well as VOCs are also known as precursors of ozone. In fact, motor vehicle exhaust, industrial emission, and chemical solvents are the major anthropogenic sources of these chemicals like CO and NOT, which can ultimately lead to the formation of ozone. What are the health effects of ozone? Ozone actually, it starts irritating the respiratory system, which can cause coughing, throat irritation, and uncomfortable sensation in the chest. It can also reduce the lung function or pulmonary function, making it more difficult to breathe deeply and vigorously. And it can also aggravate the asthma, or those who are suffering by asthma. This ozone are very harmful to them. When ozone levels are high, more people with asthma start having attacks. What is the reason behind this? That because ozone makes people more sensitive to allergens, and it starts reacting with the respiratory system, and the respiratory system becomes vulnerable to other pollutants, including biological or non-biological. So, and this is why the asthmatic people, the chances of asthmatic people having more attacks after getting exposed to ozone it becomes significant. And apart from that, it also increases the susceptibility to other respiratory infections. It also starts inflaming and damaging the lining of the lungs within a few days when one is exposed. And these damaged cells are then, actually the damaged cells are replaced like skin, how the skins are damaged, but over the time, or after some times, a new skin is formed. The same thing happens with the linings of the lungs. But if one is repeatedly getting exposed to ozone continuously for a period of month, for a very longer period, maybe months or years, this lining of the lungs can be permanently damaged, and this loss is irreversible. So the lungs function, actually this lung function becomes very, very low for permanent, and that is why the life expectancy also decreases. The next class of pollutant are polycyclic aromatic hydrocarbons. So what are the polycyclic aromatic hydrocarbons? Polycyclic aromatic hydrocarbons are basically organic compounds which contain only hydrogen and carbon that are composed of multiple aromatic rings, and they are actually found in the fossil fuels, especially oil and coal, and are produced when insufficient oxygen or other factors results in incomplete combustion of organic matter, that is in engines and incinerators, or when the biomass is burnt in the forest. pHs can also be found at high levels in cooked foods. When the meat is cooked at high temperature over a open flame, so the chances of formation of pH around the meat is significantly much, and that is also supposed to be a very dangerous thing. And some of the examples of pHs are anthracene, penanthracene, tetracene, chrysene, triple triphenyl, pyrene, pentacene, benzoapyrene, benzodiazepyrene, and ovalene. What are the health effects of pHs? pHs are known carcinogen and mutagen, as well as they have teratogenic effects. What is teratogenic effect actually? When people get some permanent disability, or a baby is born with some permanent disability, that effect or that kind of property is known as teratogenic property. As well as high prenatal exposure to POH is also known to be associated with lower IQ and childhood asthma. It can also be cause for anxiety or depression, especially among the children lower than 13 years of age. The next class of pollutant is oxides of sulfur, or SO2. SO2 is basically a toxic gas with a pungent, irritating, and rotten smell. It is mainly emitted from coal-fired power plants, although it can also be emitted from vehicles, but their contribution is very, very less. But the contribution from coal-fired power plant is highest. And under some suitable conditions, it can form sulfate aerosols or the secondary aerosols. Since it is highly water soluble, it might affect the respiratory system, especially the upper airways. It can be a reason for acid rain, which can cause severe damage to the properties and vegetation. The next class of pollutant is lead. Nowadays, lead's emission is very, very low, because lead was initially being used as anti-knocking agent in the petrol in the form of tetraethyl lead, that is PbC2H5 and nowadays this has been banned, and this has been replaced by some organic compound which is not a pollutant. So whatever the lead we are getting, it is basically the lead which was present in the past, or in the past which has become the part of dust or the roadside dust. Sometimes lead can be observed on in the indoor environment from paints and wands. So nowadays they are the major source of concern. Lead poisoning can cause severe behavioral changes, disabilities. Now, after this criteria pollutant, we can discuss about the standards that has been prescribed by the Government of India. The Government of India's nodal agency is Central Pollution Control Board, which is also known as the regulatory authority as far as the pollution of India is concerned. They have prescribed some standards for the different criteria pollutants like sulfur dioxide, nitrogen dioxide, PM10, PM2.5, PB and S3 here. So they have actually divided the places in two different categories, that is residential area and sensitive area. They have, as far as their concentration is concerned, they have also divided into two different categories. One is annual, another is 24 hours, or we can say one is daily, another is 1 year's average. So sulfur dioxide's annual average is in residential area 50 microgram per meter cube. It should be, it is the maximum limit actually, it should be 50 microgram per meter cube, and in sensitive area it should be 20 microgram per meter cube. While as far as 24 hours average is concerned, it should be 80 microgram per cubic meter in residential area, and similarly 80 microgram per meter cube in sensitive area. As far as NO2 is concerned, its concentration in residential area, so annual concentration is residential area should not be more than 40 microgram per meter cube, and it shouldn't be more than 30 microgram per meter cube in sensitive area, while it can be maximum up to 80 microgram per meter cube as far as 24-hour average is concerned. It can be 84 microgram per meter cube in residential area, and in sensitive area too it can be maximum 80 microgram per meter cube. PM10 has a limit of 60 microgram per meter cube in residential area annual average, and in sensitive area too it has 60 micro, it should be 60 microgram per meter cube. As far as 24 hours average is concerned, it cannot be more than 100 microgram per meter cube in residential as well as in sensitive areas. While PM2.5 is concerned, it should be 40 microgram per meter cube. Its annual average should be 40 microgram per meter cube in the residential area as well as in the sensitive area. And 24 hours average is concerned, it cannot be more than 60 microgram per meter cube in both residential and sensitive areas. As far as lead is concerned, it has also some prescribed limit. It shouldn't be more than 0.5 microgram. Its annual average shouldn't be more than 0.5 microgram per meter cube in residential as well as sensitive area. While as far as 24 hours average is concerned, it shouldn't be more than 1 microgram per meter cube in residential or sensitive area. NS3 also has limit. It should be 100 microgram. Its annual average should be 100 microgram per meter cube in residential as well as in sensitive area, while it can be up to 400 microgram per meter cube as far as daily average is concerned in residential and sensitive area. As far as ozone is concerned, it cannot be more than 100 microgram. It has, the division is based now, it is not based on annual and 24 hours, but on 8 hours and 1 hour basis. So 8 hours average, O3's 8 hours average should not be more than 100 microgram per meter cube in residential and sensitive area, and it shouldn't be, and its 1 hour's average shouldn't be more than 180 microgram per meter cube in residential or sensitive area. While CO's average is concerned, CO is a very lethal gas. Even its presence, a very small presence of CO can be very, very harmful. It shouldn't be more than 2 milligram per meter cube in residential. As far as its hour average is concerned, it shouldn't be more than 4 milligram per meter cube as far as 1 hour average is concerned. In sensitive area, it should be 2 microgram for 8 hours. It should be 4 microgram for 1 hour's average. As far as organic pollutants and some metallic pollutants are concerned, they have also prescribed limits. Benzene shouldn't be more than 5 microgram per meter cube in residential as well as sensitive area. These have the annual average basis. Similarly, one of the pHs, important pHs, that is benzoapyrene, shouldn't be more than 1 nanogram per meter cube in residential as well as sensitive area on annual average basis. Similarly, arsenic shouldn't be more than 6 nanogram per meter cube in residential and sensitive area, while nickel shouldn't be more than 20 microgram per meter cube in residential and sensitive area. Now, depending upon this, a novel way of indicating the total pollution, because the pollution what we talk is a combination of many different pollutants, especially at least 6 or 4 or 5 different criteria air pollutants. So, a very novel way to indicate the pollution level was invented, that is known as air pollution index. What is air pollution index? This is also known as pollution standard index. This PSI, basically what does it do? It indicates air quality data for 5 main criteria pollutants, that are ozone, carbon monoxide, PM10, sulfur dioxide and nitrogen dioxide, into a single number that can represent the worst daily air quality in an urban area. When a PSI value is 100, it indicates at least one pollutant has just reached its ambient air quality standard. I mean, whatever the prescribed limit is there, at least one of the pollutants have crossed or has reached up to that level. And if the PSI is 200, it means situation is of alert. I mean, many pollutants have crossed their prescribed limit. If PSI is 300 or more, then the situation is of warning. It means that more or less all the pollutants have reached to their prescribed limit. And if the PSI crosses the 400 value, it means the situation is a kind of emergency situation, and more or less all the pollutants have significantly crossed their prescribed limit. And in such situation, we have to shut down, we have to immediately shut down all the industrial and commercial activities. Otherwise, it can be very, very harmful to the citizen. Here it is described giving us numerical values. If the PSI value is between 0 to 50, it means that the condition is good and we shouldn't worry much. If the PSI value is between 51 to 100, we can say it is moderate, the level is moderate, and it is possible that some of the people might be affected. If the PSI value is between 101 to 109, then we will say the atmosphere is kind of unhealthy, and it can affect or aggravate the problems with those people who are having some kind of health issues or health history. And if the PSI value is between 200 to 99, then we will say the atmosphere is really very unhealthy. It means the people, those people who are having health problems, their health issues can significantly be aggravated. If the PSI value increases or exceeds 300 level, then we will say the condition is hazardous. And in this situation, some diseases might be start, or it is a kind of onset, it could be onset of some diseases. And if the PSI value is more than 400, then the situation is emergency and it can cause premature deaths of ill, especially those who are ill, and of old age. Here in this picture we can see the pollution level of some of the major cities of the world. It is Bangkok, Beijing, Bombay, etc. So here it is we have the 5 different criteria pollutants, that is sulfur dioxide, SPM, lead, CO and NO2. We can see here, and if the concentration is significantly high, it has been categorized as serious problem, and it has been indicated here by 3 star. And if the pollution level is moderate to heavy, then it has been indicated here by 2 star, and the pollution level is low, it has been indicated by 1 star, and if there is no data, it has been indicated by a dash. So we can say more or less in all the cities, all the major cities, SPM has a serious problem. I mean, more or less all the developed cities of the world, the major threat to them is by SPM. The next is carbon monoxide, and in most of the cases it has 2 star, and ozone. At some places, especially in Los Angeles and Mexico City and Sao Paulo, it has 3 star, as well as in the Tokyo. And as far as some of the Indian cities are concerned, the major threat to Indian cities are by SPM. Even the same situation is there of Calcutta and Bombay. And other pollutants which are present there are SO2, lead, CO, NO2, and O3 is not necessarily present in many of the Indian cities. Now, how these air pollutants can be monitored or how their concentration can be determined. There are different two methods for its determination. One is manual, another is automatic. In manual method, we apply different three types of method. One is pumped sampling, another is pre-concentrator, and the third one is grab sampling. In case of pump sampling, what do we do? We actually put some solvent in a impinger tube, and here you can see the figure of an impinger tube where from one side the air is getting inside and it is coming from the other side. And at the bottom of this impinger tube, a absorbent that is also known as analyzer is kept, and air actually passes through that particular absorber, and whatever the pollutants are there, depending upon the type of absorber, it can be absorbed. And the different type of absorbers are, like in case of if we have to analyze the NOx, the kind of absorber, it could be molybdenum dioxide or MOO. If it is, we have to analyze for O3, the absorbents could be iodine or potassium iodide. If we have to analyze the sulfur dioxide, the absorbents could be para-aniline or H2SO4. In fact, this method is outdated now. It is not being used. It has been used way back in 70s or 80s when the pollution analysis were started. This is also known as the titration method. The next one is pre-concentrator. Pre-concentrator had different categories. One is absorption. Absorption has again been subdivided into three different categories. They are bubblers, impregnated filter, and passive sampling. What is done in bubblers? In this case, the sample is bubbled through an absorbing chemical solution, and the pollutants that can be determined with the help of this kind of method are SO2 and ammonia. The next one is impregnated filter, and in this the sample is drawn through a filter that has been impregnated with a chemical that reacts with that particular kind of gas. The third one is passive sampling. In this we use the diffusion property of the sample, and in such type of methods we can analyze volatile organic compounds, sulfur dioxide, and ammonia. The next method is adsorption. In this particular case, the gas molecules are bound to the surface of a solid collecting substrate by intramolecular forces. Subsequently, they are stripped off by heating the substrate to 300 degrees centigrade or by solvent extraction, and then it is delivered to a gas chromatography and a range of organic compounds such as polycyclic aromatic hydrocarbons, vinyl chloride, and different hydrocarbons can be estimated. The next one is condensation trapping. In this, what do? The air sample is passed through a chamber which is cooled almost to a temperature of liquid oxygen, that is around -183 degrees centigrade, so that the volatiles are condenses out, but the air itself passes through without any change, and by this method we analyze most of the VOCs. Afterwards is grab sampling. Grab sampling are of four types of grab samplings. One is evacuated bottles. What is done in this particular case, either a stainless steel bottle or glass bottle or an inert plastic bottle is used, and what do? We make a vacuum in that bottle and we properly seal it, and we take it to the field or the place where air pollution is to be monitored, and we open that bottle. As soon as we open that bottle, air starts getting or rushing into that bottle, and then we tightly close it and we take it to the laboratory, and there we analyze the pollutant. And the advantage of this method is that instead of taking the samples to other places, we have to just carry the bottles, evacuated bottles, and we can collect the air of that particular place, bring it back to the laboratory, and we can analyze it for any particular type of pollutant. The next one is syringe. In this, what do? we empty the syringe, and the plunger is in fact pulled out, and the air is drawn inside it, and afterwards we take it to the laboratory and we can analyze it for any particular pollutant. The third one are with the use of bellows. What is done? In fact, a cylindrical collapsed bellow is expanded, and when we expand it, a vacuum is created at low pressure, and the ambient air is drawn inside it, and afterwards we can bring it to the lab for analysis. The last one is bag sampling. What is done in bag sampling? A bag which is made up of an inert material is filled by pumping the air sample into it, and the samples are then collected and brought to the we can bring to the lab. Apart from these manual samplings, there are some automatic sampling methods too, like and depending upon the character or some properties of those particular gases, like SO2 has fluorescence property. So this fluorescence property is used, and its concentration determination can be done, and the instrument is known as pulse fluorescence. And ozone has the character of absorbing the UV. So this character can be exploited for the estimation of ozone concentration. Similarly, NO has a character of chemiluminescence, and this can be exploited for the estimation of NO. While CO2 has a property of infrared absorption, and this property can be utilized for the estimation of carbon dioxide. Apart from these methods, we can do some real-time remote sensing monitoring too, and the different instruments that can be applied for the real-time remote sensing monitoring are differential absorption radar, that is also known as dial, and in fact it can detect NO, C6H6, that is benzene, mercury, sulfur dioxide and nitrogen dioxide. The next one is differential optical absorption spectroscopy, or DOAS, and this can detect NO, CO2, O3, SO2, NH3, Cl2, NO2. And the last one is Fourier transfer infrared absorption spectroscopy. This is also known as FTIR. These are remote sensing methods, and in this we need now to go to the polluted area or polluted portion from a remote place, or sometimes it can be mounted on a satellite, and the determination of the concentration can be done. Now, what are the effects of air pollutants? It has been categorized into three different types. One is local effect, the second is regional effect, and the third one is global effect. Now, starting from the local effects, what are the local effects? It is health impact, visibility reduction, material and property damage, and changing the character of the soil. In fact, WHO has ranked air pollution as one of the top 10 killers in the world. Its toll could be sometimes million per year, and it has short-term diseases. The health impacts of air pollution can be short-term as well as long-term. What are short-term effects is difficulty in breathing, wheezing, coughing, eye irritation, respiratory and lungs infection, as well as pneumonia. As far as long-term diseases are concerned, it could be bronchitis, asthma, pulmonary diseases, lungs cancer, as well as severe heart problem. Apart from health, it has a very key role to play in case of visibility. It can reduce the visibility to a significantly low. The main causative agent for the visibility reduction is haze. Haze, in fact, it is comprised of different 5 air pollutants compounds. They are sulfate, nitrates, organic carbon, elemental carbon, and cluster material. And this haze is basically responsible for the reduction of visibility. In this picture, you can see the 2 different days of one city. In one day, when the atmosphere is not polluted, and the next day, when the subsequent day, when the atmosphere was highly polluted. Apart from these, this can also cause damage to the property and material. Air pollution can harm buildings, monuments, electronic equipments, outdoor statues, plants, trees, as well as crops. whether they are in filled or in stored condition. They can also change the character of the soil. High sulfate concentration and low pH values, which is very much possibility of the atmosphere, may change the fertility of the soil. Fly ash has been linked to the soil pollution. Soil in the vicinity of coal mining areas are prone to contamination, as well as pesticides and herbicides, which are a class of pollutants, can also pollute the soil. After the local effect, the next one is regional effect. What are the regional effects? They are acid rain and greenhouse effect. Acid rain is basically a kind of rain or any other form of precipitation that is usually acidic in nature, meaning that it possesses elevated level of hydrogen ions. That is, it means the pH will be low. It can have harmful effects on plants, aquatic animals and infrastructure. Acid rain is caused by emission of sulfur dioxide and nitrogen dioxide, which react with the water molecules in atmosphere to produce acid. Both the reactions of sulfur dioxide and nitrogen dioxide are given at the bottom. Here you can see the sulfur dioxide reacts with the OH radical to form HOSO2 radical, and this HOSO2 radical in turn combines with the oxygen molecule to form HO2 radical as and sulfur trioxide. This sulfur trioxide, which is in the gaseous form, reacts with the water and forms H2SO4 or acid in aqueous solution. Similarly, nitrogen dioxide reacts with the OH radical to form HNO3. What are the effects of acid rain? Acid rains it can affect the surface waters as well as the aquatic animals. It can affect the soil. How it affects the soil? In fact, the hydrogen ion of the acid rain might react with the magnesium ion of clay, and this in turn the fertility can be significantly affected. The acid rain can also affect the forest and other vegetation. It can also acidify the oceans. It can also damage the monument. How the monuments are damaged? In fact, most of the monuments are made up of marble or limestone. Its composition is COCO3. So CaCO3 can easily react with sulfuric acid, which is the part of acid rain, to form CaSO4 and carbon dioxide. Now, after the regional effect, in fact, I am leaving the greenhouse effect because it will be covered in the global warming. So, after the regional effect, the next one is global effect. The part of global effects are ozone hole and the global warming. Now, starting with the ozone hole. What is ozone hole? Ozone hole is basically an annual thinning of the ozone layer over Antarctica, which is caused by stratospheric chlorine. Other more moderate thinnings have also been reported, which are also known as ozone hole, from the North Pole during certain weather conditions. In this picture, you can see this is the picture of Antarctica, thermal image of Antarctica in 1979 and 2008, and it actually represents the concentration of ozone in Dobson units in these 2 years. We can see in 2008 the concentration of ozone over Antarctica has significantly been reduced, while in 1979 situation was not such. Now, what are the causes of ozone hole? In fact, I already told that the ozone reacts with the chlorine ion, and in turn it gets destroyed. So, the compounds which can produce chlorine radical or chlorine ion, which are also known as ozone depleting substance, are tabulated here. They are chlorofluorocarbons, hydrochlorofluorocarbons, halogens, and methyl chloroform and methyl bromide, and their chemical formula as well as their ozone depleting potential are also given here. Among these chemicals, we can see that chlorofluorocarbon 11 has a ozone depleting potential of 1. In fact, it is considered to be the base to estimate the ozone depleting potential of other pollutants. while halon 1211 has a very significant higher ozone depleting potential, that is 5.1, and the highest one is of halon 1301, whose chemical formula is CF3Br, is having ozone depleting potential of 13. What could be the effects of ozone hole? Ozone hole can affect human, can affect animals, as well as can affect crops. If ozone hole is there, I mean ozone is depleted, it allows the ultraviolet rays to pass, and if the ultraviolet rays, which is in fact shouldn't come to the earth's surface, if it reaches, it can severely affect the humans, animals and crops. These ultraviolet rays are known carcinogen, and it can affect the skin severely. In fact, in turn it can have some cancerous effect too. The different diseases which can be caused by this UV rays are basal and squamous cell carcinomas, malignant melanoma and cortical cataract. It can also affect, this UV rays can also severely affect the eyes, and the disease which can be created by this UV rays to the eyes are known as cortical cataract. The next global effect is global warming. Global warming is actually the observed century scale rise in the average temperature of the earth. In this picture, the temperature profile over a period of around 120 years are given. We can see the temperature is continuously increasing, especially after the onset of 20th century, and it keeps on going, and now it has in fact the temperature anomaly has reached to around 0.6 degrees centigrade. Now, what are those substances which actually contribute to the global warming? There are so many, and the major are carbon monoxide, methane, nitrous oxide, chlorofluorocarbons, hydrofluorocarbons, halogens, and methyl chloroform and methyl bromide. And carbon monoxide oxide's global warming potential is considered to be 1, that is also known as base. And here in this table, a global warming potential of for 20 years of different chemicals are given. From this table, we can see that CFC12 has the highest global warming potential, that is 7,900. In fact, it means if 1 unit of chlorofluorocarbon can have 7,900 times more effect than carbon dioxide for 20 years. Similarly, if we take the case of CFC114, which has global warming potential of 6,900, it means that the global warming capacity of CFC114 is 6,900 times more than that of carbon dioxide, and that will be effective for 20 years. Now, what are the effects of global warming? The effects are sea level rise, climate change, crop pattern change, as well as the ecological imbalances. Afterwards, we can discuss some environmental legislation, like in our constitution has in our constitution environmental problems has been mentioned. Article 48A actually of the directive principle, it says that the states, it is a state's policy to ensure the protection and improvement of our environment. Article 51 says that it should be the duty of citizens of India to protect and improve the natural environment, including forest, lakes and wildlife. It is actually for the environmental problems, not in general the air pollution. There are some environmental legislations too. If someone is violating the rules, he can be booked in various IPC's codes. There are 268 of 1860 as well as IPC of 133 to 144 of 1878, section 1991 of 1908. Now, I should tell you some of the air pollution acts. it was enacted in 1981, that is also known as Prevention and Control of Air Pollution Act. It actually aims at the prevention and control of air pollution. It also aims at creating board for this purpose. And in 1987, the Factories Amendment Act was enacted. There are some protocols too, keeping in mind the air pollution. The one is Kyoto Protocol, which is very important. Kyoto Protocol actually, it's a protocol among the countries which ratify this protocol, and in fact those countries have to commit to reduce their emissions of carbon dioxide and 5 other greenhouse gases, or they should not engage in emission and trading of these gases. The Kyoto Protocol now covers more than 160 countries globally and more than 60% of the countries in terms of global greenhouse gas emissions. The next one is Montreal Protocol. The Montreal Protocol on substances that deplete the ozone layer is an international treaty designed to protect the ozone layer by phasing out the production of a number of substances believed to be responsible for ozone depletion. Since then, it has undergone 7 revisions in 1990, 1991, 1992, 1993, 1995, 1997, 1999. Due to its widespread adoption and implementation, it has been held as an example of exceptional international cooperation. Apart from that, there is also Aarhus Protocol or Persistent Organic Pollutants or POPs. This is the executive body adoption, the protocol on persistent organic pollutants on 24th June of in 1998 in Denmark. It actually focuses on list of 16 substances that have been singled out according to agreed risk criteria. The substances comprised 11 pesticides, 2 industrial chemicals and 3 byproducts contaminants. Apart from that, a body is also made that is known as to protect the globe or to take care of the global warming, that is known as IPCC or Intergovernmental Panel on Climate Change. The Intergovernmental Panel on Climate Change is a scientific intergovernmental body under the auspices of the United Nations. It was first established in 1988 by 2 United Nations organizations, the World Meteorological Organization and the United Nations Environmental Programme, and later endorsed by the United Nations General Assembly. Member of the IPCC is open to all membership of the IPCC is open to all members of the WMO and UNEP. The IPCC is chaired by Dr. Rajendra Pachauri of India. Now I think I am finished with the air pollution. So
definitely, sir, you have finished with this air pollution. You raised the term that is the Kyoto Protocol, that is many of the countries have signed this pact that they will control the emission.
They'll have to regulate the emission of various gases, especially those gases which can cause the greenhouse gases.
Basically greenhouse gases. But
if they sign this treaty, it means they have to abide the rules and law to so that they are following the norms of emission of those particular gases which can cause the greenhouse effect.
But if according to my concern and according to my knowledge, many of the major powers they have not yet signed the Kyoto Protocol with their idea that if they sign the Kyoto Protocol, then many of their businesses would be under pressure. They would not be able to have the transaction, or they will not be able to have it. That is why
this new term of carbon trading was started. So in this, in fact, now if those countries which are emitting less carbon dioxide, or they can sell their carbon footprint to those countries which are emitting more carbon dioxide or more greenhouse producing gases.
Definitely, sir. Thank you so very much for delivering such a nice lecture and making us aware of all the basic terms and terminologies with which we are not aware of. Thank you, sir. Thank you so very much.